Okay, so let's work on a problem from case 1. Case 1, again, is when m is odd, and n can be either odd or even. It doesn't matter. So in this first case that we have here, we have sine cubed, and you can see that the n is odd, and the n is a square, so it's even. So in these cases, you want to take one of the signs out and make it sine squared times sine. So let's go ahead and do that. You can probably hear my dog drinking. It's really exciting. Okay, and now we're going to take the sine squared and we're going to make it into cosine squared minus, 1 minus cosine squared. Because remember, sine squared plus cosine squared equals 1. So every sine squared is going to be 1 minus cosine squared. So let's go ahead and do that. Okay, now that I've done that, I can actually distribute this cosine squared here. All right. Now we can do a u substitution because we can let u be cosine x. Oops. And du would then be negative sine x, which means when we see the sine x dx, that is negative du. So that means this whole integral now will turn negative because we're going to be putting in negative du, and the sine x dx becomes the du. Oh, goody. We end up with a u squared minus u to the 4th du. And now we can integrate. And then we can go back and we can replace our u with the cosine of x. And I'm going to distribute this negative as well. And we have our answer.